When a student is working with a faculty member on a research project, it's a chance to develop a different sort of working relationship than what you have in a regular course where there might be many students and there's a structured curriculum and a timeline for the work. On a research project, you don't always know what you're going to find next, and new things that come up and surprise you may govern your next decisions and your next steps. So it requires constant consultation, collaboration between the faculty and the student. And this is a chance for students to really learn how faculty think about their research problems, the kinds of decision-making processes they employ, and also the kind of research methods that they use.
At Cal State San Marcos, the cool thing is that when a student wants to join a lab, they approach you, you speak to them, and you tell them about your science. And they become very interested in it. They want to work in your lab. They get to come and do hands-on science in the laboratory right here. There are often multiple students in one laboratory where the PI mentors the student, allows them to learn the skills they need, and then I also like to give them a little flexibility to come up with some of their own ideas to develop the research. We work on type 2 diabetes, and we found that wound repair is a major problem for obesity and type 2 diabetes. And some of my students have come along and wanted to study, well, what about stem cells? Does that mean that there's a problem with the stem cells within the skin? And that's one of the projects that now one of my undergraduate students is working on.
Computer science is dedicated to undergraduate research. Currently, at least 3 professors are working very closely with undergraduate students. One of them is Dr. Hade, who has 10 students, and most of them are here every day. They're working on bioinformatics, something to do with proteins causing HIV. Dr. Guillen also has 2 undergrads working on text mining, which means going through vast amounts of text to extract the information that you want. Dr. Oh Young is really into K through 12 education. So what she's doing is to create apps on Androids to teach K through 12 students.
The sorts of things that undergraduates have done, for me at least, have primarily been to collect data in association with projects that I already have ongoing, and frequently they're projects that I have graduate students working on as well. And so I'll have students, undergraduate students, go out in the field and collect preliminary data that will set up a study that will be done in more detail later, or if there's a study that's already going on, they'll go out and assist on the project and collect an additional data set while they're out there and analyze that data and write it up. I've also had students that have come in and just brought ideas to me that there was something that they were interested in, and if it seems like it supports a semester-long research project, then I'm willing to sign them up to work on something that they've come up with on their own as well.
We are a primarily undergraduate institution, and especially in physics, there are no graduate students. So when we're working with students, those students are doing everything that a grad student in some other lab would be asked to do. So from the beginning, they are assembling equipment, they're repairing equipment, they're running measurements, they're helping us analyze the data, and they're even helping us write papers. If you look around the walls in the science buildings, every research poster is not just some faculty member and some postdoc somewhere. It's undergraduate students working with a faculty member to produce these results.
Actually, just this year, I had a paper published in a peer-reviewed journal article along with 4 of my undergraduate research students. And these were projects that were done over the course of about 3 years. And so the experiments were done in 2 phases. And so I had 2 students work on one phase and another 2 were working on the other phase. And when we finally got all the data collected, we submitted it for publication, and it was just published this last year. So I think that that's an example of a successful undergraduate project in my lab. And I always strive to try to make our research projects for my undergraduates be projects that would be submittable for publication, because ultimately communicating results is what science is all about.